In this channel, we explore the rarest scientific phenomena most people never even hear about. Tonight, you're about to see something hidden inside the aurora that almost no one notices. If you leave now, you'll miss one of the strangest secrets of our planet. The aurora borealis is most often described in terms of light. Green curtains ripple across the Arctic sky, purple edges fringe the dancing folds, and red coronas bloom overhead like celestial flowers. These are the images that fill our minds when we think of the northern lights. They are spectacular, dynamic, almost hypnotic in their motion. For centuries, humans have gazed up at these displays with wonder, weaving stories of gods and spirits, of warriors and ancestors. The light of the aurora has inspired art, mythology, and scientific inquiry. It is a phenomenon of brilliance, of color, of movement. It is defined by its luminosity. But there is another phenomenon, less known, less photographed, yet equally remarkable. Sometimes within the brightest auroral displays, darkness appears. Not the darkness of a cloud passing overhead, nor the shadow of a mountain against the horizon. Not the natural darkness of the night sky between auroral displays. Something else. A void. A place where the aurora simply stops, where the light that should be there is not. A hole in the light itself. A dark shape carved out of the glowing sky. This is the black aurora. It is not the absence of aurora, it is a distinct structure within it. Imagine a curtain of green light, shimmering and flowing, undulating like fabric in a gentle wind. The light is bright, almost luminous, casting a pale glow across the snow-covered landscape below. The edges of the curtain are sharp, defined, moving in waves that propagate upward or downward. It is a dynamic, living thing, this aurora, constantly changing its shape, its intensity, its color. And then, as if someone has cut a hole in the fabric, a patch of darkness opens. It is not a tear. The surrounding light continues to flow around it, but within that patch there is nothing. Not a darker shade of green. Not a shadow. Just emptiness. Just the dark sky, as if the aurora was never there. The surrounding aurora continues to dance, but within that dark patch there is only quiet. Only the vast, cold darkness of space. The black aurora is not an illusion. It is not a trick of the eye, not an afterimage, not a camera artifact. It is a real physical feature, confirmed by decades of observation and measured by instruments flown on rockets and satellites. Scientists have photographed it, studied it, and modeled it. It appears in the data as clearly as the bright aurora itself. And yet, it remains less known, perhaps because it is subtle, perhaps because it is counterintuitive. We expect the aurora to be light. We do not expect darkness within light. To understand the black aurora, we must first understand what an aurora is. The aurora is created when charged particles from the sun, electrons and protons, travel along Earth's magnetic field lines and collide with the atoms and molecules of the upper atmosphere. These particles are carried by the solar wind, a continuous stream of plasma flowing outward from the sun at speeds of hundreds of kilometers per second. When Earth's magnetic field deflects this flow, some particles are captured and guided toward the polar regions, where the magnetic field lines converge. The collisions that follow are energetic. An electron speeding down into the atmosphere carries energy, sometimes thousands of electron volts. The atmosphere at auroral altitudes, between 100 and 500 kilometers above the surface, is thin but not empty. It contains oxygen atoms, nitrogen molecules, and other trace gases. When an energetic electron strikes one of these particles, the energy is transferred. The atom or molecule becomes excited, its electrons jumping to higher energy levels. This excited state is unstable, lasting only a fraction of a second. Almost instantly, the atom or molecule relaxes, returning to its ground state. The energy it absorbed is released as a photon, a particle of light. This is fluorescence, the same process that makes a fluorescent lamp glow. Green light comes from oxygen atoms at around 100 to 200 kilometers altitude. Red light comes from oxygen atoms at higher altitudes, above 200 kilometers. Purple and blue light come from nitrogen molecules. The colors are signatures of the elements involved, fingerprints of the atmospheric composition. Each color tells a story about the altitude, the energy of the incoming particles, and the chemistry of the upper atmosphere. But the black aurora occurs in regions where these collisions do not happen. Not because the particles are absent from the magnetosphere, but because they have been removed from the specific magnetic field lines that feed that region of the sky. The electrons that would normally stream downward into the atmosphere are, in these specific locations, diverted or depleted. They are pulled away by electric fields, drawn along magnetic field lines to other regions, or simply absent due to the dynamics of the plasma environment. This is not a random fluctuation. It is a structured, organized process, driven by the same physical forces that create the bright aurora. Without the incoming electrons, there are no collisions. Without collisions, there is no excitation. Without excitation, there is no light. The result is a dark patch, a hole in the auroral curtain, a place where the physics of light creation has been temporarily and locally suspended. The surrounding aurora may be bright and active, but within that dark region, the conditions for light emission are not met. The electrons are missing. The atmosphere is still there. The magnetic field is still there. But the necessary particle flux is absent. The black aurora is most often observed as dark spots or narrow channels within bright auroral displays. They are not static. They drift and shift, following the motion of the surrounding aurora. They can appear as small circles a few kilometers across, or as elongated streaks stretching for hundreds of kilometers along an auroral arc. They can form complex branching patterns, like dark rivers flowing through a landscape of light. Their boundaries are sharp, distinct, as if drawn by an invisible hand with a steady, unwavering line. There is no gradual fade from light to dark. There is a crisp edge, a clear demarcation. On one side, the bright glow of the aurora. On the other, nothing. These dark structures are almost always found in the lower edges of auroral arcs, where the incoming electrons are most energetic and the plasma conditions are most dynamic. They are most common during active auroral displays, when the energy input from the solar wind is high and the magnetosphere is disturbed. They are less common during quiet conditions, when the aurora is faint and diffuse. This correlation suggests that the black aurora is not a random occurrence but a predictable consequence of specific plasma physical processes. It is a feature of the system, not a flaw or an anomaly. Scientists have studied the black aurora using a variety of instruments. Ground-based cameras have captured images of these dark structures, revealing their shapes and motions. Spectrometers have measured the light emitted from the regions surrounding them, confirming that the dark patches are indeed devoid of auroral emission. Rockets have been flown directly through black auroral structures, carrying instruments that measure electron densities and electric fields. Satellites have observed them from above, mapping their distribution and correlating them with measurements of the solar wind and the interplanetary magnetic field. What they have found is that the electron density inside a black aurora can be an order of magnitude lower than in the surrounding aurora. The difference is striking. In the bright regions, electrons stream downward in abundance, creating a cascade of collisions and a flood of light. In the dark regions, those electrons are missing. They have been diverted or they have never been there. The magnetic field lines that connect to those dark patches are empty or nearly empty of the particles that would otherwise create an aurora. The black aurora reminds us that even in the brightest displays, there is darkness. And that darkness, like the light, is a product of the same physical laws. It is not the absence of activity. It is activity of a different kind. A silence within the storm. A pause in the flow of particles. A moment when the sky, filled with light, also holds a space for quiet. The particles are still moving, the fields are still fluctuating, the plasma is still dynamic. But the conditions for light emission are not met. The result is a void, a dark shape, a hole in the aurora. It is a visible reminder that the universe is not simply light or dark, but both, and that the boundary between them is not always a line, but sometimes a shape, a structure, a phenomenon of its own. The black aurora is a window into the invisible physics of space. It is a place where we can see, indirectly, the effects of electric fields, plasma flows, and particle acceleration. It is a dark shape in a bright sky, a hole in the light, a silence in the storm. And for those who study it, it is a reminder that even in the most brilliant displays, there is always something hidden, something waiting to be understood. The light draws the eye, but the darkness reveals the underlying structure. In the void within the light, we see not emptiness, but the architecture of the invisible. The black aurora is a phenomenon of absence. Where the bright aurora glows with the light of countless collisions between energetic electrons and atmospheric gases, the black aurora is defined by what is not there. No green curtains, no purple edges, no red crowns. Only darkness. But this darkness is not passive. It is not simply a region where nothing happens. It is a region where a very specific thing happens. Electrons are removed. The flow of particles that fuels the aurora is interrupted, diverted, or depleted. The result is a silent zone, a place where the usual physics of light emission is suspended. To understand electron depletion, we must first understand the normal state of the auroral plasma. The upper atmosphere at auroral altitudes is not empty. It is a tenuous plasma, a mixture of charged particles and neutral gases. The electrons that create the aurora come from the magnetosphere, funneled down along magnetic field lines toward the polar regions. These electrons are not alone. They are accompanied by ions, by electric fields, by complex currents that flow both along and perpendicular to the magnetic field. The system is dynamic, constantly adjusting to the changing conditions of the solar wind and the interplanetary magnetic field. In a typical aurora, the electron flux is relatively steady. Electrons stream downward in a broad sheet, creating a diffuse glow or a structured arc. The density of these electrons determines the intensity of the aurora. More electrons, more collisions, more light. Fewer electrons, less light. This is a continuum, a smooth relationship between particle flux and luminosity. But the black aurora is not simply a region of reduced electron flux. It is a region where the electron flux drops precipitously, often by an order of magnitude or more, over a very short distance. The boundary between the bright aurora and the black aurora is sharp, not gradual. This sharpness is a clue to the underlying physics. What causes this sharp drop in electron density? The answer lies in the electric fields that permeate the auroral zone. Electrons are charged particles, and like all charged particles, they respond to electric fields. A strong electric field can accelerate electrons, decelerate them, or deflect them from their path. In the region of the black aurora, there is evidence of strong electric fields directed perpendicular to the magnetic field. These fields are associated with a phenomenon known as sub-auroral ion drift, or SED, which will be explored in the next chapter. For now, it is enough to understand that these electric fields can create a downward flow of ions and an upward flow of electrons, or in some configurations can simply sweep electrons away from a region, leaving it depleted. Imagine a river flowing steadily downstream. The water is the electron flux, the current is the magnetic field line. Now imagine a strong cross-current, a flow of water moving perpendicular to the mainstream. This cross-current can push the water aside, creating a region of slower flow or even a stagnant pool. In the plasma of the auroral zone, the electric fields act like this cross-current, pushing electrons away from certain magnetic field lines and concentrating them on others. The field lines that lose electrons become dark. The field lines that gain electrons become brighter. This is the essence of the black aurora, a redistribution of electrons, not a disappearance. The depletion zones are not empty of all particles. Ions, which are much heavier than electrons, are less affected by these electric fields. They may remain in the region, drifting slowly, creating their own currents. Neutral gases are unaffected, of course, continuing their random thermal motions. But the electrons, the light carriers, are gone. And without electrons there is no aurora. The scale of these depletion zones is impressive. A black auroral patch can be tens of kilometers across, a dark spot in a sea of light. The channels can stretch for hundreds of kilometers, narrow ribbons of darkness winding through the auroral curtain. The boundaries can be as sharp as a few hundred meters, a remarkably crisp transition from light to dark. This sharpness indicates that the process creating the depletion is localized and intense, not diffuse and gradual. Scientists have measured the electron densities inside black auroras using instruments flown on sounding rockets. These rockets are launched directly into the auroral display, following a trajectory that carries them through the bright regions and, when carefully timed, through the dark patches as well. The instruments on board measure the flux of electrons at various energies, the density of the plasma, and the electric and magnetic fields. The data from these rocket flights confirm that the electron density inside a black aurora can be as low as 1/10 of the density in the surrounding aurora. Sometimes the depletion is even more extreme. The same measurements reveal that the electrons are not simply missing. They have been accelerated elsewhere. The same electric fields that deplete one region often create a neighboring region of enhanced electron flux. The bright aurora may be brighter because it is receiving the electrons that were taken from the dark region. This is a redistribution, a rearrangement of the plasma, driven by the large-scale electric fields of the magnetosphere. The black aurora is thus a manifestation of the dynamic nature of the auroral plasma. It is not a stable, static feature. It evolves, moves, and changes shape as the electric fields shift. The dark patches can appear, disappear, and reappear elsewhere. They can drift with the plasma flow, moving across the sky at speeds of hundreds of meters per second. They are part of the constant dance of particles and fields that characterizes the interaction between the solar wind and Earth's magnetic field. From a physical perspective, the electron depletion zones are regions where the upward current that typically flows in the auroral zone has been reversed or reduced. In a typical aurora, electrons flow downward carrying a current. This is an upward current in the conventional sense, current direction opposite electron flow. In the black aurora, the downward electron flow is diminished, and there may even be an upward electron flow, a downward current. This change in current direction is associated with changes in the electric field and the plasma pressure. The study of black auroras has implications beyond the aurora itself. The same physical processes that create these dark patches operate elsewhere in the magnetosphere, in the radiation belts, in the plasma sheet, in the solar wind. By understanding the black aurora, we learn about the fundamental physics of plasmas, about how electric fields and particle flows interact, about how energy is transported and dissipated in space. The silent zones of the black aurora are not empty. They are filled with electric fields, with ion drifts, with the subtle signatures of plasma physics. They are dark to our eyes but not to our instruments. They reveal themselves through the absence of light, a negative image of the auroral process. And in that absence, they tell us a story about the presence of forces we cannot see. As you rest, let your mind drift to these silent zones. Imagine the vast darkness of the Arctic sky, the green curtains of Aurora waving slowly overhead. And within those curtains, imagine the dark patches, the holes in the light, the places where the electrons have been swept away. These are not voids of nothingness. They are regions of intense activity, of electric fields and particle flows, of the invisible architecture of space. They are silent to our ears, dark to our eyes, but alive with the quiet physics of the universe. And in that quiet, the mind can rest. The black aurora is not merely a void. It is not simply an absence of electrons, a passive hole in the auroral curtain. It is, rather, the visible signature of an invisible flow. Beneath the dark patches, beneath the silent zones where the aurora does not shine, there is movement. Ions, charged particles much heavier than electrons, are drifting at high speeds, carving out the darkness like a river carving a canyon. This drift is called the sub-auroral ion drift, or SED, and it is one of the most powerful and organized plasma flows in Earth's magnetosphere. To understand the black aurora, we must understand SED. The sub-auroral ion drift is a narrow channel of fast-flowing ions that occurs in the evening and midnight sectors of the auroral zone. It is located equatorward of the main auroral oval, in the region where the bright aurora fades into darkness. The ions in this channel, primarily oxygen and hydrogen ions, can reach speeds of several kilometers per second, far faster than the surrounding plasma. They flow westward, perpendicular to the magnetic field, driven by strong electric fields that point radially outward from Earth. The existence of SED has been known since the 1970s, when satellites first measured the fast ion flows. Instruments aboard spacecraft such as Dynamics Explorer D2, and later missions like the European Space Agency's Swarm constellation detected narrow channels of plasma moving at speeds that seemed impossible. At first, these measurements were puzzling. The ionosphere, where these drifts were measured, is a relatively calm place. The neutral atmosphere moves slowly, driven by winds and tides. The plasma typically drifts at speeds of a few hundred meters per second. But SED channels showed speeds of 1, 2, even 3 kilometers per second, far faster than any expected drift. It took years of observation and modeling to understand what was happening. The fast drifts were not local phenomena. They were the ionospheric signatures of electric fields that extended far into space, deep into the magnetosphere. These electric fields mapped down along magnetic field lines, from the equatorial plane to the polar regions, creating the narrow channels of fast flow. The ions in the ionosphere were simply responding to these fields, drifting in the direction dictated by the electric and magnetic forces. The connection between SED and the black aurora was established later, when scientists began comparing satellite measurements of ion drifts with ground-based images of the aurora. The correlation was striking. Black auroral structures were observed in the same region where SED occurred, and their shapes, narrow, elongated channels, matched the expected geometry of the ion drift. The dark patches were not random. They were aligned with the flow, stretched along the direction of the ion motion, carved out by the invisible hand of the plasma. When a satellite flew through a said channel and, at the same time, an all-sky camera captured a black aurora in the same location, the evidence became undeniable. The black aurora is the optical signature of SAID. How does SAID create darkness? The answer lies in the electric fields that drive the ion drift. These same electric fields also affect electrons. In the SAID channel, the electric field is strong and directed radially outward, away from Earth. This electric field, combined with the magnetic field, creates a drift that moves ions westward and electrons eastward. But the effect on the electrons is more complex. The electric field can also accelerate electrons upward, away from the atmosphere, or can create a potential barrier that prevents downward flowing electrons from reaching the atmosphere. In either case, the result is the same. The electrons that would normally create an aurora are depleted. The channel becomes dark. The physics of this process is rooted in the motion of charged particles in electric and magnetic fields. The Lorentz force, F equals Q, E plus V times B, governs how electrons and ions respond. In the said channel, the electric field is perpendicular to the magnetic field. This configuration creates a drift that is perpendicular to both fields, called the E times B drift. For ions, this drift is westward. For electrons, it is eastward. But there is also a component of the electric field along the magnetic field, parallel to the field lines. This parallel electric field can accelerate electrons upward, away from the atmosphere, or can create a potential that reflects downward moving electrons back into space. The result is that the electron flux reaching the atmosphere is sharply reduced. The said channel is narrow, typically only a few tens of kilometers wide. But it can extend for hundreds or even thousands of kilometers in the east-west direction. This elongated shape matches the observed morphology of the black aurora, which often appears as long, thin dark streaks within the auroral curtain. The sharp boundaries of the black aurora correspond to the edges of the said channel, where the electric field drops rapidly and the electron flux returns to normal. The boundaries are so sharp that the transition from light to dark can occur over a distance of only a few hundred meters. This is remarkable, given that the phenomena are occurring at altitudes of hundreds of kilometers and involve processes that span tens of thousands of kilometers in space. The physics of SAID is rooted in the interaction between the magnetosphere and the ionosphere. The magnetosphere is the region of space dominated by Earth's magnetic field, extending tens of thousands of kilometers into space. It is filled with plasma, charged particles captured from the solar wind and from Earth's own atmosphere. The ionosphere is the lower boundary of this system, where the atmosphere becomes partially ionized and conducts electricity. Between them flows the ring current, a belt of energetic ions and electrons that circles Earth at a distance of several Earth radii. The ring current is strongest during geomagnetic storms, when the solar wind compresses the magnetosphere and injects energy into the system. When the ring current is disturbed by changes in the solar wind, by magnetic storms, by substorms, it creates electric fields that map down along magnetic field lines to the ionosphere. These electric fields are the drivers of SED. They are created by pressure gradients in the ring current, by charge separation, by the complex dynamics of the magnetotail. They are not steady. They vary with time, shifting and evolving as the magnetosphere responds to the ever-changing conditions of the solar wind. The sub-auroral ion drift is most intense during geomagnetic storms, when the ring current is strongly energized. During these storms, the black aurora is also most common. The correlation is clear. When the solar wind buffets Earth's magnetic field, when the magnetosphere is active and disturbed, the SED accelerates and the black aurora appears. In quiet times, when the solar wind is calm and the magnetosphere is still, the SED weakens or disappears and the black aurora fades. This connection to geomagnetic activity is one of the key pieces of evidence linking SED to the black aurora. The speed of the SED can reach several kilometers per second. This is fast, far faster than the speed of sound in the ionospheric plasma, which is only a few hundred meters per second. The SED is supersonic, and like a supersonic aircraft, it creates shocks and waves in the surrounding plasma. These shocks may contribute to the sharp boundaries of the black aurora, creating the crisp edges that are so characteristic of the phenomenon. The waves can also heat the surrounding plasma, creating secondary effects that may be observable in the aurora. The ions that carry the SED are not the same ions that create the aurora. The aurora is created by electrons, not ions. The ions in the SED are much heavier and carry much less current. They do not directly create light, but they are the markers of the electric field, the visible evidence, through their effects on the electrons, of the invisible forces at work. When we see a black aurora, we are seeing the footprint of the SED, the shadow cast by the fast-flowing ions. The study of SED has advanced rapidly in recent years, thanks to new satellite missions and ground-based observations. The European Space Agency's Swarm constellation, a trio of satellites flying in formation, has provided detailed measurements of the electric fields and ion flows in the auroral zone. The Swarm satellites carry magnetometers, electric field instruments, and plasma analyzers, allowing them to map the SAID channels with unprecedented precision. Ground-based radars such as the Super DARN network, Super Dual Auroral Radar Network, have mapped the large-scale patterns of plasma drift across the polar regions. And all-sky cameras, equipped with sensitive CCD detectors, have captured the black aurora in exquisite detail, showing the dark channels as they drift and evolve. What these observations reveal is a complex, dynamic system. The SED is not a steady flow. It pulses, shifts, and changes shape. The black aurora responds in kind, the dark patches moving with the flow, their shapes evolving as the electric fields vary. Sometimes the SED appears as a single narrow channel. Other times it splits into multiple channels, creating a pattern of parallel dark streaks. The black aurora mirrors this complexity, its dark shapes reflecting the underlying plasma physics. The connection between the black aurora and the SED is a beautiful example of how the invisible becomes visible. The electric fields and ion flows are not directly observable. We cannot see them with our eyes, cannot photograph them, cannot watch them move. They are invisible to us, hidden by the vastness of space and the limits of our perception. But their effects, the depletion of electrons, the darkness carved into the aurora, are visible. The black aurora is a window into a world we cannot otherwise see. It is the shadow of the invisible, the footprint of the hidden, the light cast by the darkness. As you rest, let your mind drift to these invisible flows. Imagine the SED channel, a river of ions flowing westward at supersonic speed, thousands of kilometers long, tens of kilometers wide. The ions are energetic, carrying the energy of the ring current, of the solar wind, of the magnetic storm. They push through the plasma, creating electric fields, creating shocks, creating darkness. Above them, the aurora glows brightly, the green curtains waving in the cosmic wind. But within the channel, the glow fades. The electrons are swept away. The light goes out. This is the sub-auroral ion drift. This is the invisible flow. This is the engine of the black aurora. The darkness is not empty. It is full of motion, full of energy, full of the quiet power of plasma physics. The ions drift, the electric fields pulse, the black aurora shifts and flows. It is a silent dance, a ballet of charged particles, a symphony of forces played out across the polar sky. In the quiet of the night, as the aurora waves overhead, the black aurora appears. Dark channels open in the green curtains, narrow streaks of nothingness carved by the fast-flowing ions. They drift slowly westward, their shapes constant, their boundaries sharp. They are the visible signature of the invisible, the light cast by the shadow, the silence within the storm. And in that silence, the mind can rest. The black aurora is not random. It does not appear haphazardly, like clouds scattered by the wind. It has structure. It has form. It has geometry. The dark patches and channels that open within the bright auroral curtain are not amorphous blobs. They are shapes with sharp boundaries, distinct edges, and organized patterns. They are, in fact, a direct reflection of the underlying magnetic field geometry. The black aurora is a map, drawn in darkness, of the invisible architecture of Earth's magnetosphere. To understand the geometry of the black aurora, we must first understand the geometry of the magnetic field that shapes it. Earth's magnetic field is not a simple dipole, not a perfect bar magnet aligned with the planet's axis. It is a complex, dynamic structure, shaped by the solar wind, by electric currents flowing in the ionosphere and magnetosphere, by the plasma that fills the near-Earth environment. The field lines are not straight. They curve, they twist, they stretch. They form an intricate web that extends from the polar regions into deep space. This web is constantly moving, constantly changing, responding to the buffeting of the solar wind and the internal dynamics of the magnetosphere. The black aurora occurs in a specific region of this web, the sub-auroral zone, just equatorward of the main auroral oval. Here, the magnetic field lines are transitioning from the closed field lines of the polar cap to the open field lines that connect to the solar wind. This is a region of strong gradients, where the properties of the plasma change rapidly over short distances. The magnetic field strength varies, the plasma density varies, the temperature varies. It is a boundary region, a transition zone, a place where the character of the magnetosphere shifts from one state to another. It is also a region of strong electric fields, the same fields that drive the sub-auroral ion drift discussed in the previous chapter. The geometry of the black aurora is determined by these electric fields and by the magnetic field that guides them. The dark channels are aligned with the direction of the ion drift, which is westward. They stretch along lines of constant magnetic latitude, circling the polar region like dark rings. The boundaries of these channels are aligned with the magnetic field lines, sharp and distinct, reflecting the rapid changes in the electric potential. The channels are not perfectly straight. They follow the curves of the magnetic field, bending and twisting as the field lines bend and twist. They are, in essence, a tracing of the magnetic field geometry, a dark line drawn along the invisible contours of Earth's magnetic shield. But the geometry is not always simple. The black aurora can take many forms. Sometimes it appears as small, circular dark spots, like holes punched in the auroral curtain. These spots are often called black patches or dark spots, and they can be tens of kilometers across. They are typically found in the lower part of the auroral arc, near the equatorward edge. Their boundaries are sharp and they drift with the surrounding plasma flow. These spots are not static. They can appear, grow, shrink, and disappear over timescales of minutes. Their circular shape suggests that they may be caused by localized vortices or instabilities in the plasma flow, regions where the plasma is swirling rather than flowing smoothly. Other times, the black aurora appears as elongated dark channels, stretching for hundreds of kilometers along the auroral arc. These channels are narrow, only a few kilometers wide, but they can be extremely long. They are often curved, following the contours of the magnetic field. They can appear as single channels or as multiple parallel channels, like dark stripes painted across the green curtain. These parallel channels are sometimes called black streaks or dark bands. They are often evenly spaced, suggesting a regular pattern in the underlying electric field. The spacing between the channels may be related to the wavelength of plasma waves or to the scale of structures in the magnetosphere. Sometimes the black aurora forms complex branching patterns, like dark rivers flowing through a landscape of light. These branches can split and merge, creating intricate networks of darkness. The shapes are not static. They evolve over time, shifting and changing as the electric fields vary. A dark spot may elongate into a channel. A channel may break into a series of spots. The black aurora is a dynamic phenomenon, constantly reshaping itself in response to the changing conditions of the magnetosphere. These branching patterns are particularly fascinating because they resemble the patterns seen in other plasma phenomena, such as the auroral arcs themselves, suggesting a common underlying physics. The geometry of the black aurora is not arbitrary. It is controlled by the physics of the plasma. The sharp boundaries are created by the sharp gradients in the electric potential. The elongation along the direction of the ion drift reflects the anisotropy of the plasma flow. The curvature of the channels follows the curvature of the magnetic field lines. In every dark shape, we can read the signature of the underlying forces. The black aurora is a natural laboratory, a place where we can observe the effects of electric and magnetic fields that would otherwise be invisible. It is a visualization of the mathematics of plasma physics, a drawing made by nature itself. Scientists have studied the geometry of the black aurora using high-resolution cameras and image analysis techniques. They have measured the shapes, sizes, and orientations of thousands of dark structures. They have tracked their motions and their evolution. They have correlated their properties with measurements of the electric and magnetic fields from satellites. The results reveal a clear relationship. The black aurora is a direct visualization of the plasma physics of the sub-auroral zone. The data show that the black auroral structures are aligned with the magnetic field lines to within a few degrees, confirming the magnetic control of their geometry. One of the most striking features of the black aurora is the sharpness of its boundaries. The transition from bright aurora to complete darkness can occur over a distance of only a few hundred meters. This is remarkable, given that the phenomena are occurring at altitudes of 100 to 200 kilometers, where the atmosphere is thin and the plasma is diffuse. Such sharp boundaries require strong, localized electric fields, confined to narrow regions. These fields are the same fields that drive the set. The sharpness also implies that the electron depletion is nearly complete. Within the black aurora, the electron flux is reduced by an order of magnitude or more, and the reduction happens abruptly. There is no gradual fade. The edge is like a wall, a line drawn in the sky between light and dark. The geometry of the black aurora also reveals the structure of the electric fields. The alignment of the dark channels with the direction of the ion drift tells us that the electric field is perpendicular to the channels. The width of the channels tells us about the scale of the electric field variations. Narrow channels indicate narrow electric field structures, with strong fields concentrated in thin sheets. Wider channels indicate more diffuse fields. The curvature of the channels tells us about the gradients in the magnetic field. The black aurora is a natural laboratory, a place where we can observe the effects of electric and magnetic fields that would otherwise be invisible. It is a visualization of the mathematics of plasma physics, a drawing made by nature itself. The study of the black aurora has also revealed that it is not a single phenomenon but a family of related phenomena. Different types of black auroral structures may be created by different physical processes. Some may be caused by upward field-aligned currents, others by downward currents. Some may be associated with the SED, others with other plasma instabilities. The geometry of the structure, whether it is a spot, a channel, or a branch, may indicate which process is at work. For example, Circular spots are often associated with localized current systems, while elongated channels are associated with extended current sheets. Branching patterns may indicate regions of complex plasma flow, where the streamlines are diverging or converging. One type of black aurora, known as the black curl, has a distinctive spiral shape. These structures appear as dark, curling features at the edges of auroral arcs, as if the aurora is being twisted by an invisible hand. The curls are often associated with shear in the plasma flow, where adjacent regions of plasma are moving at different speeds. The shear creates vortices, which then appear as dark curls in the aurora. These structures are beautiful to observe and fascinating to study, as they reveal the fluid-like nature of the plasma. The curls can be left-handed or right-handed, depending on the direction of the shear. They can be isolated or arranged in chains. They are a vivid demonstration that the plasma in the auroral zone behaves like a fluid, with eddies and vortices just like those in a river or the atmosphere. Another type, the black filament, appears as a thin, dark line stretching across the auroral arc. These filaments can be extremely narrow, only a few hundred meters wide, but they can extend for hundreds of kilometers. They are often associated with intense electric fields and strong ion drifts. The filaments may be the ionospheric signatures of narrow structures in the magnetosphere, such as thin current sheets or plasma boundaries. They are sometimes called black lines or dark streaks. They can be straight or curved, and they often appear in groups, with several parallel filaments spaced evenly across the auroral arc. The black aurora also exhibits a phenomenon known as flickering. The dark patches can appear and disappear rapidly, flickering on timescales of seconds or even fractions of a second. This flickering is not random. It is often periodic with a characteristic frequency. The frequency may be related to the ion cyclotron frequency or to other plasma oscillations. The flickering black aurora is a window into the wave activity of the magnetosphere, revealing the presence of oscillations that would otherwise be invisible. The flickering can be so rapid that it is difficult to capture with standard cameras, but high-speed video systems have recorded it in detail. The patterns of flickering are often complex, with multiple frequencies superimposed. The geometry of the black aurora is not only a scientific curiosity, it is also a thing of beauty. The dark shapes carved into the glowing sky have an aesthetic quality that is both haunting and calming. They are reminders that even in the most brilliant displays, there is room for darkness. And that darkness, when seen in the context of the light, can be as beautiful as the light itself. There is a quiet elegance to a dark channel cutting through a green auroral curtain, a sense of order and structure amidst the apparent chaos. The black aurora invites contemplation, a slow and careful looking that reveals the hidden geometry of the sky. As you rest, let your mind drift to the geometry of the black aurora. Imagine the green curtains waving overhead, the folds and ripples of the auroral light. And then within those curtains, imagine the dark shapes, spots and channels, curls and filaments, branching networks of darkness. They drift slowly, their shapes constant, their boundaries sharp. They are the shadows of the invisible, the geometry of the electric field drawn in light and dark. The black aurora is not chaos. It is order. It is structure. It is geometry. It is the visible expression of the mathematics that governs the plasma. In its dark shapes, we can see the elegance of the underlying physics, the beauty of the equations that describe the motion of charged particles in electric and magnetic fields. The patterns are not random. They are determined by the same laws that govern the motion of planets, the flow of rivers, the structure of galaxies. There is a universality to the geometry, a sense that the same principles apply everywhere in the universe. And in that geometry, the mind can find rest. The shapes are soothing, their regularity calming. The darkness is not threatening. It is simply the absence of light, a space for the eye to rest. The black aurora invites us to look, to observe, to contemplate. It does not demand attention. It simply exists quietly in the midst of the light. As the aurora waves overhead, the black channels drift slowly westward. They are silent, invisible in their motion. They are the quiet heart of the auroral display, the stillness within the storm. And in that stillness, the mind can let go of its busy thoughts, can settle into the rhythm of the drifting shapes, can find peace in the geometry of the sky. The black aurora is a phenomenon of absence. Where the bright aurora blazes with the energy of countless collisions between electrons and atmospheric gases, the black aurora is defined by what is not there. No green curtains ripple across the sky. No purple edges fringe the dancing folds. No red coronas bloom overhead. Only darkness. But this darkness is not empty. It is not a void. It is a different kind of presence, a different kind of activity, a different kind of beauty. It is the visible signature of invisible forces, the shadow cast by the electric fields and ion flows that shape the polar sky. And in this darkness, there is a profound quiet, a stillness that can quiet the busy mind. To understand the black aurora is to understand that light and dark are not opposites but partners. They are two sides of the same physical process, two manifestations of the same underlying physics. The bright aurora and the black aurora are created by the same electric fields, the same particle flows, the same plasma dynamics. They are different expressions of the same system. The bright aurora shows us where the electrons are streaming downward into the atmosphere, where collisions are frequent, where energy is being released as light. The black aurora shows us where the electrons have been swept away, where the collisions have ceased, where the light has gone out. Together they form a complete picture, a full map of the invisible forces at work in the magnetosphere. This duality is a reminder that our perception of the world is limited. We see the light and we are drawn to it. It captures our attention, fills our eyes, dominates our awareness. It is natural to focus on the bright, the vivid, the dramatic. But the darkness too has its story to tell. It tells us about the forces that are hidden, about the structures that are invisible to our eyes, about the quiet places where the usual rules are suspended. The black aurora invites us to look beyond the obvious, to see the absence as well as the presence, to find meaning in the void. It teaches us that what is missing can be as informative as what is present. The black aurora also reminds us of the scale of the universe. The aurora itself is vast, stretching for hundreds of kilometers across the polar sky. The green curtains can reach altitudes of 300 kilometers or more, extending from the horizon to the zenith. The black channels within them are tens of kilometers wide and hundreds of kilometers long. The electric fields that create them span thousands of kilometers in the magnetosphere. The magnetic field lines that guide them extend tens of thousands of kilometers into space, far beyond the orbit of the International Space Station, far into the region where the solar wind meets Earth's magnetic shield. And all of this is happening on a single planet, around a single star, in a galaxy of billions of stars, in a universe of billions of galaxies. The scale is humbling. Our own concerns, our own worries, our own busy thoughts, seem small in comparison to this vast and silent display. The black aurora is a window into the quiet physics of space. It is a reminder that the universe operates according to laws that are elegant, mathematical, and beautiful. The same equations that describe the motion of charged particles in Earth's magnetosphere also describe the flow of fluids in our oceans, the behavior of plasmas in the heart of the Sun, the dynamics of galaxies as they spiral through the cosmos. There is a universality to physics, a consistency that spans from the smallest subatomic particles to the largest structures in the universe. And in that consistency there is a kind of peace. The universe is not chaotic, it is ordered. It is not random, it is lawful. It is not arbitrary, it is logical. And we, as observers, can appreciate that order, can find comfort in the knowledge that beneath the apparent complexity of the world, there is a deep and elegant simplicity. The black aurora is also a reminder of the importance of quiet. In our daily lives we are surrounded by noise. Traffic roars in the streets, conversations buzz in our ears, notifications ping from our phones, televisions murmur in the background. The constant hum of technology, the endless stream of information, the never-ending demands on our attention. Our minds are busy, filled with thoughts, plans, worries, memories, hopes, fears. It is difficult to find a moment of true stillness, a space where the mind can rest. But the black aurora, with its dark channels and silent zones, offers a model of quiet. It shows us that darkness can be beautiful, that silence can be meaningful, that absence can be as important as presence. It shows us that there is value in the spaces between the noise, in the pauses between the thoughts, in the gaps between the events. When we watch the black aurora, we are not watching an event. We are watching the absence of an event. We are watching the places where nothing happens, where the usual processes have been suspended, where the light has gone out. And yet, those places are full of activity, electric fields, ion drifts, plasma waves, particle acceleration. They are quiet to our eyes, but not to our instruments. They are still, but not empty. They are dark, but not dead. This is a profound lesson for the mind. Stillness is not emptiness. Quiet is not absence. There can be activity beneath the surface, movement without sound, energy without display. The mind, too, can be active without being noisy. Thoughts can flow without clamor. Awareness can be present without effort. As you rest, let your mind drift to the black aurora. Imagine the polar sky, dark and cold, the stars shining steadily overhead like distant beacons. The air is crisp, still, almost frozen. The snow below reflects the starlight, casting a pale glow across the landscape. There is no wind, no sound, no movement. Only the vast dome of the sky, the scattered stars, and the waiting darkness. Then the aurora begins. Green curtains unfurl from the horizon, rising slowly, rippling and waving like silk in a gentle wind. The light is soft at first, then brighter, then brilliant. It casts a pale green glow across the snow, illuminating the landscape with an otherworldly radiance. The curtains fold and unfold, shift and flow, creating patterns that change from moment to moment. But then within that light, a dark patch appears. A hole in the curtain. A place where the aurora does not shine. The edges are sharp, distinct as if cut with a knife. The surrounding light flows around it, bending and curving, but the patch itself remains dark. It is not a shadow cast by a cloud. There are no clouds. It is not a gap between curtains. The curtains are continuous. It is a void within the light itself. Watch as the dark patch drifts slowly westward. Its shape is constant, its boundaries crisp. It moves at a steady pace, unhurried, as if carried by a deep and invisible current. It is a window into the space behind the aurora, a glimpse of the quiet sky that lies beyond. But it is not a window. It is a region where the electrons have been swept away, where the conditions for light emission have been suspended, where the usual physics has been temporarily overridden. It is a dark shape carved by invisible forces. Now imagine more dark patches appearing. Some are small and round, like dark coins scattered across the green curtain. They appear suddenly, drift for a while, then fade. Others are long and narrow, dark channels stretching for hundreds of kilometers across the face of the aurora. These channels persist, their shape stable, their boundaries sharp. They drift slowly, maintaining their form. Some of them split, branching into two or more channels. Others merge, combining into larger dark regions. The aurora becomes a landscape of light and dark, a geography of brightness and shadow, a map of the invisible forces that shape the polar sky. Notice the boundaries. They are sharp, precise, as if drawn with a ruler. There is no gradual fade from light to dark. There is a line, and on one side is light and on the other side is dark. The transition is abrupt, almost violent. This sharpness is a signature of the electric fields that create the black aurora. It is a sign of the intense gradients that characterize the sub-auroral zone, where the electric potential changes rapidly over short distances. The same sharpness can be found in the mind, when we draw clear boundaries between thoughts, when we let go of what is not needed, when we focus on what is essential. The mind, too, can have sharp edges, clear distinctions, crisp boundaries between what matters and what does not. Notice the motion. The dark patches drift slowly, steadily westward. They are carried by the plasma flow, by the same electric fields that created them. Their motion is smooth, continuous, unhurried. There is no rush, no urgency. They drift at their own pace, following the invisible currents of the magnetosphere. The mind, too, can learn to drift, to let thoughts come and go without clinging to them, to allow the stream of consciousness to flow without resistance, to observe the passage of thoughts without being carried away by them. The black aurora teaches us to move like the dark patches, smoothly, steadily, without hurry, without attachment. Notice the shapes. The dark spots are round, almost perfect circles. Their roundness suggests that they may be created by localized vortices, by swirling eddies in the plasma flow. The dark channels are long and narrow with parallel sides, suggesting that they are created by sheet-like structures, by narrow bands of intense electric field. The branching patterns are intricate, like rivers seen from above, suggesting that they are created by complex networks of current, by the interaction of multiple plasma processes. These shapes are not random, they are determined by the physics of the plasma. They are the visible expression of the underlying mathematics, the geometry of the electric field made visible. The mind, too, has its own geometry, its patterns of thought, its habits of attention, its tendencies to focus or to wander. By observing the geometry of the black aurora, we can learn to observe the geometry of our own minds. The black aurora is a natural meditation. It invites us to watch without expectation, to observe without judgment, to be present without agenda. The dark shapes drift, the light waves, the sky turns. There is no goal, no destination, no purpose. There is only the watching, the being, the quiet awareness. The black aurora does not demand anything from us. It does not ask us to understand it, to explain it, to master it. It simply exists quietly in the midst of the light. And we can simply watch quietly in the midst of our own thoughts. The black aurora is a natural meditation. It invites us to watch without expectation, to observe without judgment, to be present without agenda. The dark shapes drift, the light waves, the sky turns. There is no goal, no destination, no purpose. There is only the watching, the being, the quiet awareness. The black aurora does not demand anything from us. It does not ask us to understand it, to explain it, to master it. It simply exists quietly in the midst of the light. And we can simply watch quietly in the midst of our own thoughts. As the night progresses, the aurora may intensify or fade. The dark patches may grow or shrink. New patches may appear, old ones may disappear. The display is always changing, always in motion. But beneath the change there is constancy. The electric fields continue to pulse. The ion drifts continue to flow. The plasma continues to move. The physics continues. And the black aurora continues to be a window into that physics, a quiet reminder of the order that underlies the apparent chaos. In the same way, our minds are always changing. Thoughts arise and pass. Emotions fluctuate. Attention wanders. But beneath the change there is a constancy. The awareness that watches, the presence that observes. That awareness is not affected by the thoughts. It is the space in which they appear. It is like the dark sky behind the aurora, quiet and still, holding the display without being disturbed by it. The thoughts are the aurora. The awareness is the sky. The thoughts come and go, but the awareness remains. The black aurora teaches us about this space. It shows us that darkness can be as meaningful as light, that stillness can be as valuable as activity, that silence can be as rich as sound. It invites us to rest in the darkness, to find peace in the quiet, to let go of the need for constant stimulation. The black aurora is not a void, it is a presence. It is the presence of the invisible, the quiet, the still. It is the presence of the space in which all phenomena appear. As you rest, let the image of the black aurora fill your mind. See the green curtains waving, the dark channels drifting, the sharp boundaries between light and dark. Feel the vastness of the polar sky, the cold clarity of the air, the steady light of the stars. And in the midst of it all, find the quiet center, the still point around which everything moves. That center is you. It is your awareness, your presence, your being. It is the sky, not the aurora. It is the space, not the shapes. It is the darkness, not the light. The black aurora will continue to drift. The light will continue to wave. The night will continue to turn. But you can rest in the stillness, letting the display unfold without grasping, without resisting, without judging. You are the sky, not the aurora. You are the space, not the shapes. You are the darkness, not the light. And in that darkness there is peace. Let your breathing slow. Let your thoughts settle. Let your awareness rest in the quiet darkness behind your closed eyes. There is nothing to do, nothing to achieve, nothing to understand. There is only this moment, this breath, this presence. The black aurora reminds us that the universe is vast, that our worries are small, that there is beauty in silence. It invites us to let go, to rest, to be. And so, as the night deepens and the aurora waves, you drift towards sleep. The dark channels drift with you slowly westward. The green curtains ripple and fold. The stars shine steadily overhead. And you are at peace,